Let's start. Hi guys, thanks for attending this session and thanks for the organizers that invited me. So let's start soon with the topic of this session or a deep dive on creating a photorealistic talking avatar. So before starting, let me explain that this is a project that lasts at least 2 years, and it is very, very complex. And the algorithm was modified several times, of course, improved. And I did a lot of mistakes and study and tests and so on. Each single tip that I will share, I can say that it meant for me a month of work, maybe, or a very, very long test. So just that, basically, to say that is very complex to make an overview, a detailed overview of all the project. So the goal of the session is to provide let's say an history of my workflow or my best tips that I can provide in order to explain what I did and allows you to enlight a spark of the ideas and principle that I used in my project. Of course, if you need much more details that I can't provide in 1 hour, I will be happy to share everything with you. You can keep in touch with me by email, social network, and so on. So feel free to do that. And if I can, I will be happy to share all informations, all details that you need. So, who I am, I'm Sebastiano Galazzo. For people that don't know me, I'm Microsoft MVP for AI category, and I deal with artificial intelligence since 20 years now. I'm a CTO in a AI company based in Italy, but works worldwide, named Synapsia. And of course, one of our main goal, main project is creating avatars, but not just that. Anyway, let's start soon showing you the final result, or to summary, what we have to do is creating something, a deep learning algorithm, a project that starting from a written text is able to generate a video of a talking person in a photorealistic way. So this is the final result. This is just an example, of course.
Hi everyone, and thanks for attending this session. This is the digital version of a real person, generated from a text by a sophisticated AI, result of an intense year of research, development, and most importantly, great passion. Today we will talk about my creation. Enjoy.
Okay. To do that, we had to create most everything from scratch. Maybe you know that on GitHub you can find some projects like Web Tulip that works almost very well. So there are already open source projects that can do similar things. Why to do that from scratch? Because of the quality. Basically, the open source project that you can find, I can see that works almost well, but anyway, do not provide this final quality at that resolutions. With my GPU, I was able to create with this level of details a video frame of 640 by 640. And so it's a very, very high resolution and detail. This is the reason why we had to create everything from scratch. So let's talk about the workflow. But before, a quick introduction of application field. Of course, the main field of application are chatbots on customer care. As you can imagine, we can use Avatar to support our web chats to make conversation more engaging. In the same way, we created also a product based on landing pages that are much more engaging for a marketing campaign. Let you imagine how it is a landing page nowadays, where you users arrives and maybe there is already an AI with a chat, but it's the user that must interact with the page. With this approach, we have the opposite, or there is a human faces that starts the interaction with you, is much more engaging, and the user can ask in natural language informations about the product and so on. So you can improve a lot all it is about landing pages. Of course, in home devices like Alexa, Google Home, and so on. But finally, also in totems, information totems, like in malls or shopping center, you already are accustomed to use and to see this kind of product, but you can't interact. We already created interactive totem using photorealistic avatars. And also we had requests about the introduction of this avatar in automotive. Uh, there was a company having the goal of creating a supercar and asked us also to introduce this kind of technologies. But I guess that the main application field are chatbots, web pages, and info totem. Well, let's start about the workflow. And we said that starting everything from scratch. And when I mean from scratch, I mean from scratch, really. So you need, of course, to train a deep learning model to create your data, your starting data. So we have to start from the shooting, and we created a set based on the feature that we needed. So we did also some jobs with Adobe Premiere, After Effects for green screen removal, and so on. After that you prepared the data set that is almost a 6-minute video with a special text that has been created by our team, something that I will explain better after. We move to audio processing, that is one of the most important process, then the training, and finally, of course, the inference. When you created all these steps, you can start to make it into in production, creating a streaming server. We will see that on detail after. So let's start very soon with one of the core of this project, or audio processing. When talking about audio processing, of course, for people that are accustomed to signal processing, they know that there is only one tool that is the king of this processing, or the Fourier transform. In this case, I used, of course, the short time Fourier transform. I can't explain in details how it works. So if you don't know how it works, please, you can find a lot of resources on the web. But basically, what Fourier transform does is to have an input, in this case, an audio, because it's one dimension, and to convert from one kind of representation to another. In this case, we extract frequencies. But extracting frequencies doesn't work very well with the Fourier transform because this extraction is time independent. So a technique that we use is to use the short time Fourier transform, or basically we split our input audio into small chunks that matches with a single frames. So the first step is to extract the audio from our shooting. And of course, we have to use also a speech to text because don't forget that our goal is starting from a text, then creating a video. In my workflow, what I need is a speech to text engine. And in this case, we use the Microsoft one, but you can use the engine that you prefer. So, said that we started from a text, we have our audio. We use the short time Fourier transform to extract frequencies for each chunk, where each chunk is matched to each frame. We will see better how we will do that. But first, let me explain something else. The humans can detect sounds from frequencies that ranges about from 20 hertz to 20,000 hertz. But the human voices ranges between 100 and 3020 hertz. 3020 hertz for males, maybe women can reach also 5000 hertz, but more or less this is the range. So the first thing that is very, very important is that we don't need all frequencies. And if you deal with deep learning, with machine learning, you know that the more you are able to cut useless information, the better it is. So the first thing that we have to do is to cut useless frequencies in order to avoid also noises for our input. But that's not enough because our brain works when talking about audio in a logarithmic way. What I mean? I mean that we are much more able to distinguish sounds that are in low frequencies against sounds that are in high frequencies. And as I said before, we do that in a logarithmic way. Well, there is an algorithm that is named MFCC that basically convert our frequencies following this law. And also, what it does is to reduce our input because, dealing with the Fourier transform, with my parameters, I use a range that is more or less 4096. You have to half that value, but even if you cut a lot of useless frequencies, there are still a lot. With this algorithm, also we have the ability to reduce the number of our input. In this case, is 128. So another parameter that is very, very important is still talking about the Fourier transform, is the size of our window or the size of the cluster that we have to match with a single frame. This size is very, very important. And after some calculations, based on the fact that the video is 25 frames per second and the audio has 60,000 hertz and is mono and so on, based on that calculations, we can say that the op length, that is the value that we have to use with our library, that to say is Librosa in this case, is 614 And this is the perfect value that we used. It's also important that the libraries wants another parameter that represent the overlapping between the window. This is good for most of tasks, but based on our research, what we have to do is to avoid this overlapping. And this is something that can improve a lot your result. But based on a lot of tests that I spent months and nights blood making a lot of research in this field. What I realized is that the perfect solution was to manipulate this data like it was an image, because the idea is to use different windows for the same frame. So more, the idea, making this also other tests, was to include in our input the chunk before, one chunk before and one chunk after. That's why basically when you move your lips, the position, the shape of your lips may depends on what you were talking, what you are going to talk. And side to this 2D, two-dimensional input, because it's treated like an image, we have another window that is centered on my chunk, but is wider than the value that I proposed before. And this is more or less the graphical representation of my data set, or how it works. Well, let's talk straight about the model, the deep learning model. Maybe someone of you knows what autoencoders are. Basically, I used an autoencoder architecture. An autoencoder, for people that don't know what it is, you have to imagine it like two neural networks connected together, where in this case we say that the part on the left that is named the encoder takes one input, and based on several convolutional layers, it tries to extract, to understand, to extract the most important features of my input. And we have a middle layer that is one of is the most important, basically, that is named the latent code, where you can find all the most important informations, or basically is a representation, a fingerprint of your input. The decoder, on the other side, based on that input, is able to reconstruct your input. This is a well-known architecture, and you can find a lot of documentation about autoencoders. Of course, I had to modify a lot of things, and here I'm sharing the most important tips and the core of the deep learning core and autoencoder, and then the architecture. Let's talk about the audio encoder. As I explained before, I use two inputs for the audio encoder. One input is 2D, and one input is 1D. And this is the architecture that I used with a latent code having a size of around 12. Well, but this is the first innovation. I say innovation because at the time of speaking, in my knowledge, I never met an architecture like that, but maybe someone else had the same idea. Anyway, I'm sharing with you what I did, and this is really the core that was game changer to reach that kind of results. So I explained the autoencoder as one entity, or there was just one input and one encoder. In this case, I have two autoencoders. One encoder is just for audio, and I shared the architecture in the slide before, and the other encoder is for a reference image that we modify according to the audio input that I will have. I used residual blocks and skip connection architecture, of course. But what I did, and this is the most important tip, that I produced after month of test, is here in the Latin code. As you can see, thanks to arrows, I connected to the Latin code just the audio part. That because in the first attempts, I connected also images and audio, but the amount of information that comes from images is far away bigger the amount of information comes from audio. And so the deep learning model learned much more from the video part and not from the audio. That was instead the most important driving input for my output. So what I did is to do not connect the video encoder to the Latin code, but just using it as skip connectors, and to connect the audio encoder to the Latin code. So in this way is only the audio that drives the frame generation supported by the reference image. But how we do our mouth animation? So basically, the idea comes from inpainting. Inpainting is a computer vision technique that maybe you already seen using Photoshop, for example. Uh, by the way, is the feature by what you can delete objects in the scene by drawing a mask, for example. You can remove people, you can remove objects, and the AI is able to reconstruct the missing part thanks to information that are all around the area that you want to reconstruct. In this way, in this case, we have to do something different because I don't have to reconstruct based on informations that rely on images, but I have to reconstruct based on information that comes from the audio. So this is the reason why, for example, the previous architecture. So the main idea is to mask the reference image that you use as input in the architecture that I showed you before. And thanks to the audio encoder and the skip connections, the AI is able to reconstruct the missing portion, the masked portion, according to the audio feature. So, if in that chunk I need to say A or E or O, the mouth is reconstructed according to my head position, but also to the audio information. Well, um, here I can share something, some information that I collected thanks to a lot of tests that I did along this month. Uh, Really, to arrive to that solution, the, I spent a lot of energy. So this is the final result. I can share some of the most important. For example, I realized that I got uh, really a game changing results. Simply adding, of course, affine transformations, so scaling, rotation, different luminosity, and so on. This was vital for the algorithm, as if the image is steady, uh, I reach overfitting too quickly. So this helped to avoid overfitting. But one of the most important discovery was that based on the timing of the training, on the stage of the training, I got different and better performances using different shapes for shapes and sizes for my mask. For example, I realized that at the beginning of the training, I needed the algorithm to work better having a bigger mask and more statically mask. But when the accuracy going to improve and works better, the model worked better having a smaller mask and much more dynamic. So what I did is a workflow totally created from scratch that based on the status of the accuracy, what changes the shapes of the mask. So, for example, here for stage 2, as you can see that I can apply a dynamic mask or not. What I mean a dynamic mask? Dynamic mask, it means that the mask follows the shape of my mouth, of my jaw. So I had to use, in this case, DLib is a deep learning model for landmark extractions that helped me to draw better masks. Well, also was I realized that helped a lot to enable or disable the training of the audio encoder at some stages. That because I already told you that the video part it contains much more information than the audio part, but also it means that in training they have different speeds. And so if I continue to train the video part, the model, sorry, because the video part is still not ready, for sure the audio encoder is already available, already got the convergence, and then you need to disable its training. Else, the risk is that you reach overfitting on the audio encoder. Well, let's say that we started from a text, we use our speech to text to create our audio. Thanks to audio processing, we split that audio in small chunks according to the rules that I already explained, and we extracting frequencies, extracting the reference frame of a small shooting. We use that information as input. The output is another frame, of course. So what we do is to produce all the frames for the exact length of our audio, and then that matches with the length of our text. So what we need now is to put everything together. And I use a tool that is very, very known, that is FFmpeg, is very, very famous and need no presentation. And I want to share a very important tip that improve the final quality. Or to use the optical flow. What is optical flow? If you see your favorite Netflix series, if you put in pause the movie, what you see for sure is that the background is freezed correctly, but moving objects are blurred according to their movements. So there is a movement estimation. Uh, why is done that? Is done that to improve the smoothness of what you see. And in this case, is really important that you do that, because something that I not shared is that our shooting were done in 4K at very high frame rate, because I needed to extract all frames as high quality images, and then I need to use a very high frame rate. Uh, I don't want to add more about that, so please believe me. What happened is that when using a very high um, frame rate, your final animation is not smooth. Is something that happened. So this is the reason why applying an optical flow filter to your final result helps a lot. Anyway, your final result, your final movie could be a bit shaky. Why that? Because the AI works too well. We can say works too well. Let's say that based on the text that we prepared, the algorithm is able to learn very, very well how to reproduce the shape for the vowel A, O, and so on. But this shape doesn't take into account how was my position one frame before or one frame after. So happen often that everything is very, very correct about the shape created for my mouth, but again is shaky. To avoid that, to solve that, I used the interpolation, or I skipped some frames and interpolating them in order to improve a lot the smoothness of my final result. But this is very, very important and is amazing at the same time. It could be also magic, let's say. What I did is to don't use interpolation on pixels, on images, but using a property of autoencoder uh, to improve the final result, I did the interpolation on the latent code of my model. So let's say that I have to interpolate from 2 frames and skip, for example, let's say 4 frames. What I do is to use just the encoder and to extract the latent code of the source frame, the latent code of the destination frame, make the interpolation of the latent code, and the user interpolated informations with the decoder to create a new frame. A new frame that in according to the position, to the head position, body position of a transition between the source image and the destination images without working on a pixel. That improved dramatically the final quality, and it is also faster because I used also computer vision algorithm with OpenCV, for example, that worked on pixels, and very, very slow, and the final result is not realistic. So this technique was something that again was game changer for the project. Here is an improvement that I did. Basically, the idea comes from the fact that with the previous approach, what do we do is, let's say, to skip to frame. But that skipping is fixed, let's say. Well, it works very, very well, but could happen that you can skip important informations because maybe you have some pauses or you can talk faster at the beginning of the sentence and slower at the end, or vice versa, and so on. So um, unless you talk in a monotone way, is could happen that you skip frames that instead I wouldn't skip because contains an important information, the important sound. To improve that, I used an API coming from Microsoft. Is from Azure Cognitive Services. It is still in beta, I guess. At least the last time that I used was still in beta, but it works. It works for English, they say, but I tested also in Italian, other languages, and works pretty well also for other languages, even is not supported. Anyway, what it does, that API that basically extract the VCM. A VCM is a combination of, let's say, it provided the shape of your mouth based on a classified sound. This API was born for character animation, for something else. But what I did is to use that in this context to understand, to extract the best timestamp where the sounds occurs. So having this information, because the result is a JSON that tells me this is the timestamp and this is the sound associated that I found. In this, with this information, making some calculation, I can say, okay, in this case, you have to skip to frame, but at this point of the audio, you don't have to skip frames because the guy is talking faster, and after you have to skip one frame. After 5 seconds, maybe I can skip 4 frames, for example. So in this way, you can skip frames like in a chirurgical way. So like it was a surgery, in a very, very accurate way. And again, this was something that improved the future our performances. Well, we are almost going to finish. Once we created the inference engine, now we have to use it because, of course, we need um, to release our service. And here there is the architecture that we created using Microsoft Azure. Of course, you can do that with other tools that you prefer. But in this case, we use the Azure Bot Framework. That is a tool that we find very, very useful for bot creation. And of course, it was born for text interaction, but the idea was to match, to put the avatar side to the chart. And how it works. Basically, each time the customer makes a question, this question is sent to our NLP engine that answer with some text. This text is fixed because, of course, the text associated to an intent is fixed. And then in background, we created already the portion of video associated to this text. So is sent a request to our streaming endpoint in order to extract the streaming video of that sentence, that speaking sentence. There is a mechanism that basically what it does is that there is an idle video of the avatar that is not talking. When arrives the request or to play this sentence, there is a fading overlap, and then we reproduce that video. And when it finishes, again with a transition, we show again our idle chunk. We used also a DRM service in order to protect in the way that we can, of course, our content. And basically, this is the architecture that we used. So this is the list of the services that we used for our server. I will be happy to share more detail if you need. Again, you can keep in touch with me, and I will be happy to explain better. Anyway, the best software is useless if it's not sold. And we realize that it's very difficult to sell the technology. Maybe you can say that something similar is made by Synthesia, and I agree, but we don't sell the same service because services like Synthesia just provide you the final video. So it's up to you to create something with it. We provide a final product that is most different. We provide yes the avatar technology, but together with the NLP AI engine behind the avatar and a lot of other services together. And more or less, this is the structure that we manage for our product that we hope will be released in the next month. It's still in beta, and this is one of the applications that we made. At the beginning of the speech, I told you also that this technology can be used also for web pages, for landing pages, not just for customer care. And that could be an idea of how it could work. So let you imagine this page like a landing page where the users arrived here. You can find yes some banner, but you can interact if you want, but also there is the avatar that engages the final users with a conversation that, of course, is focused to sell something. So something that is really far away, more engaging than standard landing pages. Well, I guess that I said everything. Just something that maybe I missed about the video at the beginning for the shooting is that our team is made by people that are expert in computational linguistic. What they did, they created a text long 6 minutes, as I told you, that contains all sounds of the English language or Italian language or the language that you want to reproduce. So we, thanks to that approach, so studying the best sentence to say, we were able to create something with just 6 minutes of video against hours and hours of recording that could be requested from other services. So that's all. I hope that I was able to explain at a high level, more or less, what we did, what it is the architecture. Again, as I said at the beginning of the speech, this is a very, very complex project. Is not possible to explain all the details in just 1 hour. The goal is to provide an overview of the workflow, of the idea behind, and in order to help you to understand what we did, but also to realize business possibilities that, using this kind of technologies. Again, if you need more information, I will be happy to keep in touch with you. Here are my contacts, my email, my LinkedIn profile, and I will be happy to share information with you. So that's all.